All right, so let's kind of run through this here together. So probably the most challenging part of this assignment was writing the equations for the system. Once you're able to do that, it should have been pretty easy to get the system into your calculator and then use the calculator to solve, right? Okay, well, what I want to do today is have you guys help me go through and make the equations here then for the system, since that seems like maybe the trickiest part. Okay? So number one says you worked 14 hours last week and earned a total of $96 before taxes. Your job as a lifeguard pays $8 per hour, and your job as a cashier pays $6 per hour. How many hours did you work at each job? So how many variables are going to be in this problem? No. No. Read the last sentence. 2, right? Because how many jobs do we have? So again, the last sentence typically is going to be tell you the number of variables, right? So it asks for how many hours did we work at each job. 2 jobs, 2 variables. So I'm going to use L to represent the hours that we spent lifeguarding and C to represent the hours that we cashiered. Sound good to that? And again, I like to use meaningful letters for my variables if I get to pick the variable names rather than just like X and Y. Because halfway through the problem I'm going to forget which one X is and which one Y is. But if I use like L and C, I'm going to be like, okay, I remember what L is. You know what I mean? Oh. Okay. So, if we have 2 variables, how many equations should be in our system? 2. All right. Can somebody tell me one of those 2 equations then? Andrew. Okay. So we can say 6C plus 8L is equal to 96. So what Andrew observed is if I get $96 and I make $8 per hour lifeguarding, well, the amount of money I make from lifeguarding is $8 per hour times the number of hours I spent lifeguarding, right? Similarly, if I make $6 per hour as a cashier, 6C or $6 per hour times the number of hours is going to give me the amount of money I made cashiering. If I add up the income from each of those 2 jobs, I should get the total income. Does that make sense to everyone? Okay. What's the second equation that I can write here? Nicholas. Very good. C plus L is equal to 14. We know we worked 14 hours last week, and we have 2 kinds of jobs that we did. So you have the hours that you spent cashiering plus the hours you spent lifeguarding. Worth pointing out that when we write our system, we got to make sure our variables line up vertically. So you guys did a good job of making sure that happened here. But if your variables don't line up vertically like that, and you try to type your system into your calculator, you're not going to get the right answer. All right, so when I put this into my calculator, I get L is 6 and C is 8. So 8 hours cashiering and 6 hours lifeguarding. Do we need to run through how to do this in the calculator again? Spent a lot of time yesterday doing that. Okay, we'll do it one more time. So, I'm going to go turn my calculator on. I'm going to go to the matrix menu, press second, and the matrix button. I'm going to go over to the edit tab, pick one of my matrices. The matrix I need to make is a 2 by 3 because I have 2 equations but 3 spots in it. And I'm just going to type in the coefficients exactly as they appear. So 6, 8, 96, and then 1, 1, 14. Once I've done that, I'm going to exit back to the main screen. I'm going to go back to the matrix menu. This time I'm going to go to the Math tab. I'm going to scroll down the Math tab until I see the command RREF. I'm going to select that command, and I'll go back to the matrix menu and select that matrix A that we just made. Close my parenthesis and press enter. And it outputs this matrix for me. The way I interpret that is I see 1C plus 0L is equal to 8. So C is equal to 8. And 0C plus 1L is equal to 6. Or just L is equal to 6. Everybody okay with that? And the way I know which one is L and C is because it matches up down here. The first column has the C's in it, so the first column is my C's. The second column, my system had my L's in it, so the second column is my L's. Cool? All right. I'll take your silence to be uncool. 2, during one calendar year, a state trooper issued a total of 375 citations for warnings and speeding tickets. Of these, there were 37 more warnings and speeding tickets. How many warnings and how many speeding tickets were issued? How many variables do we have to solve here? 2. We have the number of warnings. I'm going to call that W. And then the number of speeding tickets, I'm going to call that S. Everybody's okay there? So I have two equations I should have, or two variables, I should have two equations. What's one of the two equations that I can write here? Andrew. Good. W plus S is equal to 375. And I know that because I'm told that we had a total of 375 citations, and it goes on to tell me citations are made up of warnings and speeding tickets. So that should be easy. Everybody good with that one? Okay. So what's the second equation going to be? Well, it's going to come from this sentence. There were 37 more warnings than speeding tickets. So, if I had 10 speeding tickets, how many warnings would I have gotten? $47, right? Because it says 37 more warnings than speeding tickets. Everybody agree with that? So I can say that W is equal to 37 plus S. Everybody agree with that? Notice how I did the problem numerically before I did it with variables to make sure it made sense based on the sentence there, right? Now the way I've currently written that system, can I type my equation or this system into a matrix as it's currently written? No. Why not? The variables don't line up, right? Look at where the S is. So what am I going to do? I'm just going to subtract S from both sides in the second equation. So everything lines up nice and pretty. Now I can get this into my calculator. And when I do that, I get S is 169 and W is 206. We okay there? Number 3 says, a nut wholesaler sells a mix of peanuts and cashews. The wholesaler charges $2.80 per pound of peanuts and $5.30 per pound of cashews. The mix is to sell for $3.30 per pound. How many pounds of peanuts and how many pounds of cashews should be used to make 100 pounds of this mix? How many variables? Well, how many things are they asking for? Two, right? What are the two things they're asking for? Good. So I'll use P for pounds of peanuts and C for pounds of cashews. Okay. So I have two equations. How many variables should I have? Or I'm sorry, two variables. How many equations should I have? Two. What's one of those equations I could write here? Very good. So if we're told we're going to make 100 pounds of the mix, and the mix is made up of peanuts and cashews, just beat the pounds of peanuts plus pounds of cashews should give me 100, right? There's nothing else in that mix other than peanuts and cashews. Everybody happy there? Okay. What's the second equation going to be? So it's tempting to write this, right? But this is not quite right, because the units don't make sense in this equation. In the first one, 2.8p, we have dollars per pound times pounds, which would give me dollars as the unit. Everybody agree with that? Similarly, for this second piece, again, pounds or dollars per pound times pounds would also give me dollars. Just dollars. But we have that set equal to dollars per pound. That doesn't make sense from a units perspective. What do we need to multiply 3.3 by so that the dollars per pound turns into just dollars? 100. Very good. Why 100? Because it's 330 pounds per mix, or dollars per pound of mix, and we have 100 pounds of mix that we're making. Good. That's a little bit tricky there, getting that times 100 at the end. Does everybody see why the times 100 needs to be there? Can we see how the units were helpful in figuring out whether our equations were correct or not? Those of you that are in a physics or chemistry class that have done some unit conversion this year should feel rather comfortable thinking about things that way. All right. So when I solve this system, I get P is equal to 80 and C is equal to 20. 4. At a pizza shop, 2 small pizzas and a liter of soda and a salad cost $14. 1 small pizza, a liter of soda, and 3 salads cost $15. And 3 small pizzas, a liter of soda cost $16. What is the cost of 1 small pizza, 1 liter of soda, and 1 salad? How many variables? 3. Good. So 1 is the cost of the pizza, 1 is the cost of the soda, and 1 is the cost for the salad. Okay. We got 3 variables. How many equations am I going to need? 3. Good. What's one of those 3 equations? Okay, so let's write it this order though. P plus L plus 3S is equal to 15. When we write our systems, typically we like to write them on the right hand, where the answer's on the right hand side. And if you enter it as a matrix, it has to be that format, or you're not going to get the right answers out of it. Andrew. Great, I'm ready for the next one. Okay, so 2P plus L plus S is equal to 14. Notice where we're getting these from, right? This is actually quite easy writing the equations here for the system, because it's literally given to us in each of these sentences. Do we see that now? Oops, I guess I forgot to keep highlighting that line. What's the last equation got to be? Good. I'm going to include, though, plus 0 here, because we got no salads. I'm only writing the plus 0 there to remind myself when I'm typing my matrix in. Got to remember to put a 0 there, or things kind of get goofed up. Right? We saw that happen before in the other sheet, right, where I skipped a variable and some of us didn't put a 0 there and got goofy answers. So, $5 for a pizza, $1 for a liter of soda, and $3 for a salad. That should have been, hopefully, pretty easy to write that system. You guys agree? Maybe the easiest system to write here on the homework. So far, anyways. Since just there's like one sentence is one equation. You know what I mean? Okay. 5. The attendance at a rock concert was 6,700 people. The tickets for the concert cost $40 for floor seats and $25 for all other seats. The total income from ticket sales was $185,500. How many floor seat tickets were sold and how many other tickets were sold? How many variables do we have for this system? 2. Okay. I'm going to use F for the number of floor seats and capital T for the number of other tickets. Notice I'm using capital T as opposed to lowercase t. What's the problem with lowercase t? It looks too much like a plus sign. That would confuse the bejesus out of me in my system, right? So, all right. What's one so we have 2 variables. We need 2 equations. What's one of the equations we can write? That's correct. Andrew, you got the other one? Yeah. Good. And when I solve that system, I get that we had 1,200 floor seats and 5,500 other tickets. Okay. 6 says a company sells party platters with varying assortments of meats and cheeses. A basic platter comes with 2 cheeses and 3 meats and costs $18. A medium platter comes with 3 cheeses and 5 meats and costs $28. And a super platter comes with 7 cheeses and 10 meats and costs $60. What is the cost of a meat and a cheese? How many variables do we have here? 2. We have the cost for the meats and the cost for a cheese. The cost for a meat and the cost for a cheese. Okay? So how many equations should we write? 2. Okay? What's one equation? Okay, that's 1. What's another one we could write? Okay. But what do you notice here? We have another set of information, so we could write a third equation here. What would it be? Great. Now, if I tried to solve all 3 equations with a matrix, bad things happen, right? You need to have like a 2x3 or a 3x4 to be able to do that RREF and get an answer out of it. So what do I do here? We pick 2. And depending on which 2 we picked, something different happens. So if I use equations 1 and 2, cheeses cost $6 and meats cost $2. If I did 1 and 3, cheeses cost $0 and meats cost $6. And if I use equations 2 and 3, cheeses cost $4 and meats cost $3.20. What can I say about the pricing model at this deli? It's not consistent, right? Is that typically a good way to run a business? Probably not. Funny story, the reason that I wrote this problem this way, where we have some inconsistent pricing going on, I remember as a high school student going to Burger King, and there's a man outside protesting Burger King. He had like a picket sign and was handing out leaflets about the inconsistent cheese pricing at Burger King, because it was like 20 cents to add cheese to a hamburger, but like 35 cents to add cheese to a Whopper, even though it was like the same slice of cheese. Which is a weird thing to get worked up enough to make out leaflets and picket about. But that's literally, I thought it was strange then. I think it's strange now, but it's a weird story that I remember. And that's why I wrote this problem, so I could share that weird experience with you guys. So, pay attention to the cheese pricing. My bets is that a lot of these fast food restaurants still do this. Have some inconsistent cheese pricing for these condiments. Which again, bizarre to me, but whatever. Alright, 7 says you're planning to turn a triangular region of your yard into a garden. The vertices of the triangle are 0, 0, 5, 2, 3, 6, where the coordinates are measured in feet. Find the area of the triangular region. Is this a solving system problem? No, this is like an area of a triangle problem, right? That's what it's asking for. So remember we had a formula for this. It's plus or minus 1/2 times the determinant of x1, y1, 1, x2, y2, 1, and x3, y3, 1. So just to let you guys know, it doesn't matter which point you put in which order. So if I had used, say, I started this and I did 3, 6, 5, 2, 0, 0, it doesn't matter. You're still going to get basically the same answer. The only thing that'll differ is the sign on the determinant. But if you use the plus or minus appropriately, you end up with the same answer anyway, so it doesn't really matter. Okay, so when I do this, I type in that matrix into my calculator and take the determinant. I get 12. And since 12 is positive, I know I want the positive because I need my area to be positive. I don't get 12, guys. I get 24 because the answer is 12. But I just use the plus or minus to make sure my answer is positive. So whatever sign I need to choose there to end up with a positive answer, that's what I do. Pretty okay with that? Okay. 8 says, write the equation of the standard form quadratic function that passes through the points -4, -3, 0, -2, and 1, 7. So I remember that my standard form quadratic looks like ax squared plus bx plus c is equal to y. So to be able to write this equation, I need to figure out what 3 things? A, B, and C. Okay? That's 3 variables. I'm going to need 3 equations, right? To get one of the equations, I'm going to take a value for x, plug it in for the x's, and then take my value for y and plug it into the y. So my first equation could be a times -4 squared plus b times -4 plus c is equal to -3. And then I'm just going to do that 2 more times with the other 2 points. I'll type that into my calculator to solve the system. And I get the following. So I would write my final answer as y equals 1.25x squared plus 7.25x minus 2. Is that an easy system to come up with? Heck yeah, it is, right? All I'm using is that standard form equation. And plugging in x's and y's. This one, honestly, should be the easiest of the systems to be able to write. You agree with that? Because you know exactly what the equation needs to look like right from jump. Okay. We have 2 more on the back. For 9, our answer would be this. And for 10, our answer would be that. Make sure that you guys have tried doing one of these solving or finding the standard form equation for a quadratic problems. So here on 9 and 10, I skipped writing out the system and just wrote down the answer so that you can try doing them yourself and be able to check them. You should have done these already, but if you hadn't gotten around to it quite yet, I'm going to stop here and just give you the final answer and let you try it on your own. Make sure that you can get the system you need to get those. Okay. So